Hi, today we're going to be talking about rational expressions. Rational expressions are important because we have to learn about how to simplify fractions. And you guys know that I like to give you examples first before I actually explain the lessons. And let me go ahead and go over here to the right. So basically, what a rational expression is a fraction divided by a fraction. And so this is basically the idea of what we're going to learn. You know that 1/2, it's the simplified form of 2 over 4. And it's a simplified form of 2 over 4 because 2, it's divisible by 2, and 4, it's also divisible by 2. So they have a common factor, okay, which is the number 2. 2 divided by 2 gives me a 1. 4 divided by 2 gives me a 2, and I get that 1/2. So 1/2, it's the same as 2/4, but 1/2 equal to 2/4 is the same as 8 over 16. I can also think as 8 over 16 as 8 and 16 have factors of, well, let's see, 8 is 2 times 4, and 16, let's just say it's 4 times 4. And you can see that one common factor is the 4, but I still have the 2 over 4. Now, the 2 over 4, it's the same as this one that we just did. 2 over 4, we can write it down as 1 times 2, which is, over 2 times 2. 2 and 2 divide out, and I get the 1/2. So that's basically what we call the simplified form. So you can see that basically what we're doing is just simplifying fractions. That's basically what we're going to be doing right now. We're going to be simplifying rational expressions. So let's go ahead and get started. A rational expression is a polynomial divided by a polynomial. So let's go ahead and write the word here, polynomial. A polynomial divided by a polynomial. We should know what a polynomial is already. Here's an example of a rational expression. Here's another example. I'm giving you 3 different examples of rational expressions. Adding and subtracting rational expressions. If we have the same denominator, we're going to add or subtract the numerator and keep the same denominator. Okay, here's example number 1, and you can actually see it here on the notes already. We have 3 over 7 plus 2 over 7. And you can see that the only thing that we do is we only add the numerator. 3 plus 2 is 5, but we keep the same denominator, so it's 5 over 7. If I have a fraction, if they have the same denominator, then I only subtract the numerator. 3 minus 2 is equal to 1. And the denominator, we keep it the same. The same rule is going to apply to rational expressions. Let's just say we have to add and simplify. So in this particular case, the first thing for me to check is that they have the same denominator. And they do. And because they have the same denominator, the second part that I'm going to check is to see the sign or the operation symbol. In this case, the operation symbol says to add them. So the only thing that I'm going to do is I'm going to add the numerator. So then I can see that I have an x squared. There's no other x squared. This is going to be x squared. Then negative 5x plus 2x, that will give me a negative 3x. And then negative 15 plus 5, that will give me a negative 10. And then keep the same denominator, x squared plus 5x plus 6. And that will be the simplified, that will be the answer when you add them. Now, how can you check that it's completely done? You gotta try to see if it's possible to actually factor out the numerator and the denominator more. So let's see, what are factors of the numerator? I have negative 10, and I need to factor negative 10 where the sum will be equal to the middle term, which is negative 3. So then 5 and 2. 5 and 2 will give me a negative 3. Negative 5, positive 2, that will give me a negative 3. So then I can actually factor this as x plus 2. and x minus 5. Okay, that will give me the sum to be negative 3. I'm going to check the denominator. I'm going to do the same thing in the denominator. I need to work with 6. The sum has to be 5, 3, and 2. Okay, so that will give me whatever I want. So this will be x plus 2 over x plus 3. I'm sorry, times x plus 3. Then you can see that we can actually simplify this out because these two divide out. And so then my final answer in a simplified form is x minus 5 over x plus 3. And this will be considered to be your answer. Okay. The example that I gave you, the two examples that I gave you before, you were not able to simplify the answers right here. You couldn't really simplify the 5 over 7 because it was already in a simplified form, and the 1 over 7 was already in a simplified form. But let's just say it was like 2 over 14. If the answer was 2 over 14, you can simplify it more. And that's basically what I did on my example. Now, what should we do when we have two different denominators? If we have different denominators, okay, then what we're going to be doing is we're going to be looking for a common denominator, okay? Recall, when adding 1/2 and 2/3, we look for the common denominator, which is what we call the LCD. I'm going to put here the common denominator, which is the LCD. Then we write equivalent fractions for both and add them. 1/2 plus 2/3, okay? As you can see, basically what we want is the same denominator. And so we're going to be doing the 1/2 plus the 2/3. I have to find the common denominator between the 2 and the 3, which is, those are my two denominators. So then what I do is I say, what can I multiply them by so I can make them the same number? We can say, well, I can multiply the 2 by 3 and I can multiply the 3 by 2. And if I multiply them out, then I can get that denominator of 6. And also the numerator, okay, look at this part right here. So what we do is we get the 1/2, okay, I'm going to erase. I get the 1/2 and I'm going to multiply by the blue missing number, numerator and denominator, okay. So it will be like 1/2 and then multiply by this 3 and then plus the 2/3. And I'm going to multiply those 2/3 by this other number that we were able to find, which is the 2, numerator and denominator by 2. And so now 1 times 3, that will give me a 3. 2 times 3 gives me a 6. 2 times 2 gives me a 4. And then 3 times 2 gives me that 6. Now you can see that this fraction right here, it's this one. This fraction right here, this other one. We're making them the same denominator. Okay. If they have the same denominator, you can add the numerator and then you keep the same denominator. Okay. So then the answer will be 7 over 6. Of course, the fraction that I'm kind of giving you as an example, you can do it in the calculator. The problem is what happens when you cannot do them in your calculator. Okay. For example, example 2. So if you look at example 2 right here, it says, go ahead and add and simplify. And so then I have the 7 over 6x squared plus 2 over 9x. And so then the first thing that I am going to look at is the denominators. And I'm going to try to make them the same. So the first thing to do is I want to make, not make, but find a number, find the LCD, basically. Okay, so this is what I'm going to do. I'm going to factor out the 6. I know that that is 2 times 3, and then I have 2 x's because this is x squared. And then the 9x is 3 times 3, and then I only have 1x. Okay, let me go ahead and use orange here. Okay, I can see that both of them have a 3 in common, and they both have an x in common. But then I am going to multiply by the extra values that they have. So, for example, Mm, this one has a 2, but this one doesn't. So I'm going to multiply this one by 2. Okay, this one has an extra x right here. So I'm going to multiply by this x. This one has a 3. I'm going to multiply by that 3 right here. I'm going to highlight it. Okay, this is what I am looking for. Okay. Now, when you do this, you can see that you're making them exactly the same. If you were to multiply them out, okay, 2 times 3 gives me a 6. 6 times 3 gives me an 18, x squared. If you multiply this other one, 3 times 3 is 9. 9 times 2 gives me an 18, 18x squared. So then you can see that this will be equal to your LCD. Okay, let me go ahead and copy my fractions. So this is 7 over 6x squared. Okay. And I am going to write my miss number. The 6 belongs to this one, and so the 3 is the one I'm missing. Okay, then plus 2 over 9x, and you can see that I am missing in here the 2x. Okay, so then I'm going to continue right here. Now I'm going to multiply. 7 times 3 gives me a 21 over 18x squared plus 4x over 18x squared. Now, because they both have the same denominator, I can add the numerator. 21 plus 4x over 18x squared. They are not like terms, okay? 21 and 4x. So then there's nothing I can add. This is my final answer. Now, is it possible to simplify? Not possible to simplify either, because 21 has factors of 3 and 7, but 4 has only factors of 2 and 2, and 18 does not have factors of 3 or 7, and so then that's it. That will be the answer. We'll go ahead and do the other example that I have over here. This is a subtraction. You're going to do it the same way, okay? And so the first thing that you want to do is, once again, you want to factor them out. So let me go ahead and start here with the 5x squared plus 15x. Okay, so I'm going to factor it out. So I can factor it. The greatest common factor will be 5x. And then I'm left with x plus 3. And then I'm going to get the other one. Okay, so this is x squared plus 6x plus 9. And I can factor this one as, let me see, this is 9. Factors of 9 where the sum is 6. Well, 3 and 3. 3 times 3 gives me a 9, and the sum is 6. So x plus 3 and x plus 3. Okay, let me go ahead and make them the same. Okay, so then let me go ahead and use red. I can see that this one has a 5x, but this one doesn't. I can see that this one has only one x plus 3, but it's missing one of them. So I'm going to multiply by that missing one. Okay, now when I do this and making them exactly the same, this is equal to the LCD. 5x times x plus 3 times x plus 3. Okay, so now with that in mind, I'm going to multiply the missing ones. But notice that I'm going to write it down in a factored form. Okay, so this fraction, I'm going to write it down in a factored form. And this fraction also, I'm going to write it down in a factored form. So here we go. This will be 7 over, the factor form is the green color here, 5x over x plus 3. And then I'm going to multiply by the red color, x plus 3 numerator and denominator, and minus 9 over x plus 3, x plus 3, multiply by the red color, 5x. Okay, now I'm going to multiply across. So then this will be here. When I multiply, you can see that I'm going to distribute. So think like if, you have only a huge big numerator and you kind of ignore the denominator for a little bit. Okay, so then let me go ahead and use a different color. I'm going to multiply 7 times x plus 3. And so when I do that, there's going to be 7 times x. That will give me a 7x. And 7 times 3, that will give me a 21. So this is 7x plus 21. When I multiply this one, I got to consider that negative. Okay, so it's a negative 9 times this 5x. That gives me a negative 45x. And then copy only one of the denominators. 5x, x plus 3 times x plus 3. Okay, I'm going to combine the numerator. So then that will give me, let's see, I have positive 45. I'm sorry, 7x minus 45x. That will give me a negative 38x plus 21. Over the same denominator, 5x, x plus 3 times x plus 3. Okay, now let me see, is it possible for me to try to simplify this more? Well, 38, let me see, 38, it's only divisible by 2, yeah? It's 2 and 19. But 21 is 3 and 7. They don't have anything in common, so then this will be my final answer right here. Okay, this is the way you guys are going to be working with this simplifying rational expressions. And so now you can take a little break and try to see if you can do some of these problems in section 1.5. Okay, let me go ahead and continue right here. Let's go ahead and talk about linear equations versus nonlinear. Okay, so now linear equations, basically what a linear equation is when the degree of the variables is 1, okay, versus nonlinear. Nonlinear, well, something different. So let me go ahead and give you a few examples. For example, x plus y, it's equal to 3. It's considered to be linear because the degree of the exponents are 1. If I give you another one, let's just say I give you 7x plus 10 is equal to negative 6. The exponent on the variable x is equal to 1. So it's considered to be linear. I can give you any variable that I want. I can give you a w minus 7z is equal to negative 72 minus w. As long as all of them have a degree 1 in terms of the variables, then it's considered to be linear. Okay. I can also have fractions in here. I can have the 1/2 in here. It's not affecting the variable exponent. Okay, nonlinear. Something that it's nonlinear, well, it's something that has something different than degree 1. For example, y it's equal to x squared. Okay, the x squared has degree 2, not degree 1. Or if I give you 1 over x, it's equal to 1 over x plus 1 minus 3. It's no longer linear either because the exponents are, or your variables are in your denominator, so it's not considered to be a linear equation anymore. Okay. In fact, that one's a rational expression. Yeah, but it's a nonlinear, yeah, equation. Something, let me give you one more example. So let's just say I give you something like the square root of x plus 3 is equal to negative 10. Something like this is not considered to be linear because you have a radical. And so the degree of the variable is not 1. Okay, here are some examples. Okay, because this video is getting recorded, I'm only going to do 2 examples, and then you are going to be stuck with the other ones on your own. So I'm going to do only problems 1 and 2, and you will be stuck with problem number 3 on your own. Okay, so here we go. Okay, so then here we go. What I'm going to do, the first thing to do is Let me give you maybe some steps right here. The steps are to clear the fractions, clear fractions, clear parentheses, clear brackets, mm, clear braces, basically any grouping symbol you want to get rid of first. Clear decimals. Okay. That's what we want to get rid of first. Okay, so in this case, that's my first step. So I'm going to get rid of the parentheses. So I'm going to distribute. That will be a negative 3w. Negative 3 times a negative 4, that gives me a positive 12, plus 5 equal to 10. I'm going to distribute this negative. That negative is going to change the sign in here to the opposite sign. So then that's going to change into a negative w, a negative 1. Okay, second step. Combine each side. Okay, so combine the like terms. Okay, so 12 and 5 are like terms. This is negative 3w plus 17. It's equal to 10 and negative 1 are like terms. That's 9 minus w. Okay, step 3. Move the variables to one side on numbers with no variables on the opposite side. So we want all the variables on one side and then equal to all the numbers on the other side. Okay, and by doing that, we are going to be adding the opposite sign in front of your variable. So for example, here, I'm gonna move the negative 3w, but because it's a negative 3w, I'm gonna change its sign to a positive 3w. And when I do this, this is going to cancel out here because a negative 3w plus a 3w is 0. So this is 17. This is equal to 9. Negative w plus 3w, that's equal to 2w. Okay, wait a second. I'm going to repeat step 3 again because I have a 9. I'm going to subtract the 9, the opposite sign. Okay, so 17 minus 9, that will be what? 8. It's equal to, this cancels out, 2w. Okay, one thing that, sometimes students ask, wait a second, how do you know to take away or not take away? You can see it as, in a room. If you have all these people inside a room and you're supposed to count how many people are inside the room, but if somebody's leaving, you have to subtract that person because the person's leaving, yeah? But if a person comes into the room, you have to add that person that comes into the room. So it's almost the same thing. We're just changing the sign to its opposite sign when we're doing this. Okay, the last part that I need to do is step 4. Do multiply or divide. So we'll say here multiply or divide. In this case, the opposite of multiplication, 2 times w. The opposite of multiplication is division. So I'm going to divide by 2. And so 2 divided by 2 gives me a 1. So w is equal to 8 divided by 4. I'm sorry, 8 divided by 2 gives me a 4. W is equal to 4. This should be my answer right here. Okay, now this one says go ahead and solve. And can you also check your solution? Let me go ahead and tell you how to check your solution. You can check your solution on your calculator. Okay. So hopefully you will be able to do this on your calculator. So let me go ahead and tell you how to do it on the calculator. You are going to get both sides of your original problem. So in this case, I'm going to copy the left side. So this is negative 3, and then minus 4 here, and then plus 5. But then you can see in here that I'm going to plug in the 4, the value of the variable. You can plug it in into the calculator the way you see it. So can you please plug this into your calculator the way you see it? And when you do, you should get the answer to be equal to 5. Okay, now I'm going to get the other side. 10 minus, then plus 1 here. And I'm going to input the value of the variable, which is 4. Put this into your calculator the way you see it with those parentheses, and the answer should be equal to 5. If you get the answers to be the same, then that means that your answer is right. And that's it. That would be your answer. Your answer is W is equal to 4. Let's just say that when you check it, one of your answers in here, it's not 5. You're going to have to re-put it into the calculator just to see that you didn't make any mistakes. Let's just say you input it again, and again, you don't get the same answers, then you probably you did it wrong. So you have to erase it and you have to redo the problem again. Okay, let's go ahead and do the last example here. Example number 2. Okay, assuming that you guys kind of copy the steps. Remember, the steps are clear the fractions, parentheses, brackets, braces, decimals, basically any grouping symbol, combine each side, move the variables to one side, the numbers to the opposite side, then you're going to multiply or divide, and then last you will check. I forgot to add the word check here. Step 5, you will check. Okay, I need a little bit of space right here, so I'm going to erase my steps. You should have them written on your notes already. Okay, so here we go with this here. Okay, so I'm going to get started right here. I have a fraction. The first thing I want to do is I want to get rid of that fraction. And so then the way we're going to get rid of this fraction, it's by multiplying by the LCD. So I need to find the LCD of my denominator. I have all of these denominators, and the 2 has its own denominator, which is 1. So, well, I have 3 and 7, because the 3 repeats twice, and then the 1. Okay, well, I can multiply this one by 7 and this one by 3, and I can see that the LCD is equal to 21. 21. Okay, so now I'm going to multiply this fraction right here by 21. Each fraction by 21. So this is 21 x minus 6 over 3 plus 21 x over 7 equal to 21 times x plus 1 over 3 plus 21 multiplied by 2. Okay, so here we go. Notice that I'm multiplying, okay? I am multiplying, not multiplying the numerator and denominator. The denominator in this case, everything in here has a 1. Okay, so now I'm going to multiply across. But before I do that, look, 3 divides the 21. So this 21 is going to become a 7. Okay, so now I'm going to multiply the 7 times the x minus 6. So that is going to be 7x minus 42. Okay, now I'm going to move on to the next one. Plus, well, 7 divides the 21. That will give me a 3. I'm going to multiply that 3 times this x. That gives me a 3x. It's equal to 3 divides the 21. That gives me a 7. I'm going to multiply that 7 times the numerator. So when I distribute here, that will become 7x plus 7. And then there's nothing to cancel in here or to simplify. So 21 times 2 plus 42. Okay, what did we do? We did the first step. The first step is to clear the fractions. Okay, so now, second step, combine the like terms on each side. 7x and 3x, that gives me a 10x minus 42. That is equal to a 7x. Then I have 42. 42 plus 7, that gives me a 49. Okay, step 3, move the variables to one side, numbers to the opposite side. So in this case, I am going to move the 7x. Now it really doesn't matter which one you move. Okay, 10x minus 7x, that gives me a 3x. 3x minus 42, it's equal to 49. Okay, then I'm going to add the 42. Okay, let me go ahead and do it over here. Okay, let me go ahead and move over here. So then I have 3x minus 42 is equal to 49. But then we're going to add the 42. So then 42 plus 49, that gives me a 91. Divide both sides by 3. And x is equal to 91 over 3. You guys will have to do the checking on your own. And that will be the answer. I'm sure that this is the answer, but make sure you check because you don't want to struggle on your test by checking. Okay, let me go ahead and move on to at least introducing the last topic before I end the video. We're going to talk about rational equations. In fact, we kind of did one of those rational. No, it's not irrational. Thank you. I had to come back and check it. Okay, linear equations versus rational equations. Okay, so let me go ahead and at least introduce it here. Okay, linear equations, we kind of talked about them already. We said it's just something that has a degree 1. So x plus y is equal to 10. Or 3x minus 7 is equal to 6x minus 1. The degree of the variables are 1. Rational equations, if we have 1 over x plus 2, it's equal to 7 over x minus 1. This is what if we consider to have a rational equation because the variables are in the denominator. Okay. The domain. What's the domain of this rational expression? It says it's all real numbers except for -2, but the domain of x plus 5, it's all real numbers. So to simplify, but also to keep the original domain, we can write x squared plus 7x plus 10 over x plus 2 equal to x plus 5, where x cannot equal to -2. Okay, so let me go ahead and quickly discuss what the domain is. Domain, super important topic right here. Okay, so after this, I will end this video. Domain. Okay, so if I have 6 divided by 2, the answer is 3. Because I can actually check 2 times 3 gives me a 6. If I do 5 divided by 1, the answer is equal to 5 because 1 times 5 gives me a 5. 10. Divide this by 2 gives me a 5 because 2 times 5 gives me a 10. What's 0 divided by 3? It's 0 because 3 times 0 gives me a 0. The problem is if I reverse the order, what's 3 divided by 0? If you say 0, 0 times 0 gives me a 0. Wait, I have a 3, not a 0. So this is not right, yeah? This is not right, this is wrong. What if I do 3 over 0 is equal to 3? Well, 0 times 3 is 0, not 3. So it doesn't work, okay? This is what we called undefined. Undefined, not possible. And this is what we call your domain. Your domain is a part where your denominator is equal to 0. And so when we're going to be talking about the domain is we're going to be trying to find the values where your denominator is 0. Okay, so let's go ahead and talk about the problem that I kind of gave you right here, which is this one. X squared plus 7x plus 10 over x plus 2. Okay, so just go ahead and consider that one. Okay, it's just the problem right here. And what I can see is the denominator, yeah, x plus 2. And so as soon as I see the x plus 2, I know that my denominator cannot be equal to 0. So if I solve for the variable, I subtract the 2. X cannot equal to negative 2. And the problem is if x was equal to negative 2, negative 2 plus 2 will be equal to 0. And it's impossible for me to have a 0 because I already described to you that we cannot have a 0 in the denominator. So now I know where this restriction is coming from. Now, what about the final answer? Well, the final answer is just a simplified form. You factor out the numerator. We have 10, and then we want the sum to be equal to 7. And so the factors of 10 are 2 and 5. And so this is x plus 2 times x plus 5 over x plus 2. But this simplifies because the x plus 2 cancels. And so in a simplified form, we know that this rational expression simplifies to be x plus 5. But you still have to mention that your domain x cannot be equal to negative 2. Even though the negative 2 we're working here, we're talking about always the original one. The original is this one, so you cannot just ignore that negative 2. Okay, I'm going to stop right here and then I'm going to continue with another separate video. Have a great day. Bye.